Yeah, so you bring in a guy from New Mexico to talk at a Texas water conference right after lunch, so most of you guys will be asleep. I'm to try and keep you awake. Since I'm from New Mexico, I grew up in Hobbs, New Mexico, so I'll put my best West Texas accent on so you guys will understand me. When I go to Washington, D.C., they go, "What part of Texas are you from?" And I'm saying, 2 miles east of or west of the Texas state line is a big 2 miles in New Mexico. So I'm glad to be here. I work a lot with Michael Weber here at the University of Texas on energy and water related issues. I generally talk about water demands for the energy sector, but today I'm here to talk about energy demands for water treatment and directions that we see to address some of these emerging energy-related and water-related issues around the country and around the world. So I'm going to start off and give you a international perspective. Sandia is a national security laboratory. We work on issues that impact national security. Natural resource issues and water issues are one of the largest growing areas of conflict worldwide. I'll show you why here in a second. And then I'll take that to regional issues and local issues. And we're seeing a lot of regional issues in the United States and in North America around water also. And how do you address these solutions when we're looking at things like climate change, population growth, economic growth, all of which require significant additional water resources. So the next slide, am I supposed to run it myself? I can. So I can run it, or okay. And does the laser work? Yeah, laser works too. Let me just, I don't want to do, how do I get rid of that thing? There, ask him to do it. Good. Works every time. What I have here is, I just want to point out water stress worldwide. We like to talk about situations where we have droughts, and droughts kind of imply short-term, 1 or 2 year events that if we can get through it, we're done. And I think that's the problem when we talk about drought in the United States or drought in Texas. It's like it's here for a year or so and then it'll be gone. I'm going to show several slides that suggest that this is a trend that's going to last probably for the next 75 years. And so this is not a one-time occurrence last year or this year. It's going to be the trend that occurs for the next 75 years or so, and something that we need to address and figure out how to do that. This is a slide on water stress, which really looks at water supply availability, fresh surface water supply, or fresh water supply availability versus demands and population. And what you can see is that we have issues and concerns across the U.S. My main point here is if you look at, that works there, doesn't work that well, that's all right. Look at the Southwest and northern Mexico. We're probably as stressed in water supply availability for the population that we have as any place else in the world. But if you look at North America, much of the western United States and even parts of the eastern United States are also in the same water stress concerns. If you look at southern Europe, northern Africa, the Mideast, also in the same kinds of issues associated with decreasing fresh water availability. The other areas that I would like to point out are areas that are fast growing from an economic standpoint. India, parts of northern China, and even Southeast Asia are seeing huge water stress. That's in the northern hemisphere. In the southern hemisphere, we've got Argentina, parts of Brazil, southern Africa, and Australia. The point that I want to make is we're already at a point in the world where we have major portions of major continents that are experiencing water shortages and water stress as we talk about today. If we lay on top of that climate change, the major concerns associated with climate change are in the mid-latitudes. The mid-latitudes are 30 degrees north and south of the equator. which is exactly where we live today. Texas, New Mexico, Arizona, California, southeastern United States are all in the mid-latitudes. Northern Africa, southern Europe, India, China are also in the mid-latitudes. So any issues with climate change, any concerns about reductions in water availability are going to impact those areas more significantly. In the southern hemisphere, mid-latitudes include Argentina, the Amazon, southern Africa, and Australia. So those are the regions of the world that are going to be impacted by water stress even more than they see it today, which suggests that as climate works its way through and we look at tree ring data, my view of that data is that we're in about a 300-year drought. We've been in that situation since about the mid-1800s. So the good news is we're about 150 years into the drought. Bad news is we've got another 150 years to go. I think the extreme is going to be in about 2070 if you look at the data and my projections from the data. So that suggests that we have time in the next 40 years to see 3 or 4 more droughts of record or extreme droughts. And if we don't start preparing for it now, we're going to be in trouble in the next 30 to 40 years, the next 3 to 4 decades. So I'm here to talk about what can we do now to move forward. I think the best thing would be if all the politicians got together and decided that this was the biggest issue and move forward on it. But as you know and I know, that as soon as it rains once, a quarter inch of rain, everybody says, boy, not a drought anymore. So I don't think our political systems are set up to handle droughts, and we're going to have to look at it a different way. And the reason I say that, if you go back and look at some of these mega droughts, these long-term periods of water shortage over the last 2,000 years from the tree ring data, you can pretty much pick out where civilizations disappeared were in those periods. The Roman civilizations, in the Southwest, the Anasazi, the Mimbres cultures. So these political systems aren't able to figure out how to handle these long-term trends. We've got to come up with something else. In this newest drought, my expectation is places like Phoenix and Tucson, they may be the societies that we see might disappear. We'll see. I don't know. So what have we done in the United States? What are our resources? If we want to address these water supply issues, what kind of resiliency do we have? What kind of resources do we have available for us to use? On the left-hand side is the surface water supply availability in the United States. In the 1900s, the Bureau of Reclamation, TVA, Bonneville, major effort to build large reservoirs in the United States to increase fresh surface water supply capacity. We haven't built many large reservoirs in either Texas or the United States in the last 20 to 25 years. We essentially are maxed out on our fresh surface water supply withdrawal capacity. And if we look at climate change and some of the impacts in some of those reservoirs in the West, we're looking at reductions of 10 to 15% in water availability. So in the next 4 to 5 decades, while we're going through the worst of this long-term drought condition, we're probably going to have less fresh surface water to rely on. So what we've done in the last 40 years is we've moved toward the right-hand graph, which is relying more and more on fresh groundwater. And from that, we have exploited those groundwater resources at a rate that is very much unsustainable. We have huge impacts on major aquifers across the United States associated with overpumping, salinization of the aquifers, saltwater intrusion along the coast. And it's just not in the Southwest. We're talking about major aquifers that occur in, this works, you probably can't see it, in the Midwest, around Chicago, in the Southeast, and much of the Pacific Northwest. And so states that you don't generally think of having water shortages or water supply issues, like Wisconsin, like Illinois and Indiana and Minnesota, and Washington State and Oregon, are also experiencing water supply issues. So we're stressing our fresh surface and groundwater resources to a point that is extreme, and trying to look at how do we address these emerging water demands in drought conditions. This is a study that was done by the GAO about 10 years ago, looking at what states are suggesting water supply shortages. And you can see the state of New Mexico doesn't really have a problem. We decided not to respond to this survey. So if you guys are having problems in Texas, just move over to New Mexico. We don't have a problem. Or California, Nevada. But you can see here that these are from under normal conditions. Study done of the state water managers. So states, again, like Oregon, Wisconsin, Idaho, Minnesota, Wisconsin, Washington, that you don't think of as having water supply problems, are experiencing regional water issues. So we have a fresh water supply concern in the United States. We need to address it. How do we do that? We're going to have to look at other options to address those. So real quickly on the energy water nexus, it takes a lot of water for energy development, whether that's gas shales, oil sands, electric power generation for cooling water. But on the water side, if we look at some of these alternative water resources, we've got huge issues with pumping conveyance associated with energy. So this connection of energy and water is going to be a big player as we move forward, and we need to take that into consideration as we look at alternative supplies and alternative resources in the future to address our water demands. How big is the demand of water for the energy sector? And the graph on the left just shows that everything in purple, which is about half of the water withdrawn in the United States on a daily basis, is used for energy. Not all of that is consumptive use, but that water has to be available to run power plants, to run refineries. So water is a big concern associated with energy development. And there are things that we can do in the energy sector to minimize water use and reuse water. We got some people from EPRI, Kent Zamet's going to talk about that today, later on. But the fact of the matter is the energy sector is a big competing demand for water and needs to be considered in long-term projections as we move forward. We've already seen water supplies being a major concern for energy development across the United States. Now, this isn't all of the areas. This is just representative. And a couple of things that I wanted to point out. Some of these plants are power plants. Some of them are biofuels plants. And even the plant in California is a renewable energy solar project. So none of these technologies, energy technologies, are free from having water demands that need to be looked at and considered. But the reason that I have these shown is that we're seeing water issues with energy development across the country. This is not a Southwest U.S. problem. It's a countrywide situation. So our situation in the United States mirrors very closely the water situation worldwide. In other words, competing demands for water supplies, demands for economic growth, which means that you need additional energy resources as a competing demand. With population, you need additional water for the food for that population, additional water. So there's many competing demands for water supplies, and they impact long-term economic growth and economic development. This is just a curve and a graph that shows some of the gas shales. Gas shales is in the paper all the time. Huge resources of gas shales in the United States. In Texas, tremendous reserves. They do require water, 3 million to 6 million gallons of water per frac. A lot of that water is lost. Some of it comes back. If you can recover it, it is pretty brackish. We need to look at how we can utilize and reuse water in this industry to address gas shale, because Gas shales and natural gas are going to be a big player in future energy development. They have lower greenhouse gas emissions. They're cheaper. They're easy to permit, less costly to implement. And with a power plant that's gas fired, it's much less water use. Just wanted to mention some of the ethanol issues associated with transportation fuels. It's a big issue. We try to talk about using domestic supplies of energy. It does have a water component and a water impact. And you can see the areas that are going to be impacted mostly by ethanol production. And the Midwest is already have issues with water supply availability. So we're going to see competing demands in those areas for some of these emerging energy supplies. So from the research roadmap that we did several years ago for the Department of Energy, here were the main things that were highlighted. Improved water resources planning and management. We've got to get the energy groups and the water groups talking together. Kilowatt hours and million acre feet don't go together. They can't understand them. So there's going to be huge need to do a much better group of integrating resources planning. I think that that's true across the country, across the world. We do not integrate resources planning well. Land resources, water resources, energy resources. We're going to have to do a much better job of that. Improved water use efficiency in both power plants and biofuels. But the last one is what I'm going to talk about for another couple of slides here, which is the utilization of non-traditional water resources. What's the best way to do that? How do we do that? What can we do in the short term to try to maximize water use for developing economies? Here's one of the things we can do. Look at brackish groundwater. That's on the left. This is a chart that I've modified from the USGS and just put in the United States studies that have been done on brackish water availability. We have a ubiquitous supply of brackish water. It generally underlies the fresh water, but it's there, it's available. Some people talked about produced water this morning. There are water resources that are non-traditional that can be utilized. Some of these things are too brackish to handle today, but we can move forward on utilizing a number of alternative water resources to supplement supplies in many areas. Texas is lucky. A lot of brackish groundwater and a lot of produced water. One thing I wanted to point out is that people have been using non-traditional water resources for the last 2 decades. Everyone talks about, well, it's too expensive to do desal, it's too expensive to do water reuse. And if you look at the trends in desal and water reuse in the United States since the 1990s, we've seen a tremendous logarithmic growth in utilization of these technologies. Wastewater reuse is growing at 15% a year, desal 10% a year. The reason for that is that the costs of these new supplies of water are actually cheaper in many locations than freshwater resources. We still have some issues. If you look at on the right, the energy demand for these new resources is anywhere from 3 to 5, 10 times more energy use intensive, which means it costs more money. But it's things that we're going to have to do and look at. And the research today in many organizations is to try and get the energy use of these technologies down. Most of the water supply in the United States that's alternatively used is brackish groundwater. There's a couple of reasons for that. And water reuse is that they're really less expensive today. But what has happened and is growing is that if you look at the desalination research, costs. This is with a slide that was put together by myself, the Bureau of Reclamation, and then there's another university that you guys haven't talked about today that does desal research, University of Texas, El Paso. I thought that was in Texas, but no one mentions them. So maybe you ought to talk to those guys out there. Ed Archuleta will be more than happy to get you in touch with those guys. They're pretty good. I've worked with them a lot. But you can see that the freshwater supplies and the desalination costs for the next marginal cost of water is actually getting to the point where many locations it's cheaper to do desal. And I think Ed's probably going to talk about why they did that in El Paso. We're seeing this, we talked at lunchtime, the speaker talked about Australia. Australia's major direction for water supply security is desal. All their major cities are on the coast. All the major cities are going to coastal desal. So it's here today. It can be done. It doesn't really require any government support. You can do it. They'll move forward. We talk about alternatives. This is about my next to last slide. I just want to point out that the costs associated with energy, or excuse me, with water development, much of the cost is for energy. And I have here the energy demand for different types of water supply options. If you look at freshwater importation, which some people talked about today, 10 to 18 kilowatt hours per 1,000 gallons. Seawater desal is in the same range. But if you look at brackish groundwater desalination and aquifer storage and recovery using wastewater reuse, they're actually much cheaper and much more energy efficient than some of these other options. So I think you're going to see huge growth in water reuse and brackish water desal. And actually, coastal desal is probably going to be competitive with bringing in freshwater supplies or moving freshwater supplies around the state of Texas. There are some research directions that we identify. There's going to have to be some major research directions in looking at materials in power plants, refineries that are compatible with degraded water supplies. So the civil engineers, the environmental engineers, mechanical and chemical engineers, these are areas that are going to be very important to be working on. We're going to see non-traditional water used for fuels, for energy, for domestic industrial applications. We need to leave those fresh surface water supplies that we really need for us, for drinking water, for agriculture, for ecology, and reuse in these non-traditional water resources for anything that's industrial. So let's see. The last one I have here, there's another university in Texas that not many people talking about, which is Texas Tech. I don't know why. Maybe they think Lubbock is really close to New Mexico. All right. But one of the things that I wanted to mention is alternative energy resources are generally considered unreliable because they come on and off. The wind blows at night, and that's exactly what this shows from Texas. In Lubbock, if you're in Lubbock, really the wind blows all the damn time in Lubbock, but it really blows a lot at night. The good thing about that is when you need your water is early in the morning and late in the afternoon, so this matches pretty nicely with the water demand. Solar, even though it's intermittent, can be used for pumping and treating water. It's highest during the day, and you can store water very easily, and so you can treat during the day and have the water for the evening and the following morning. So a lot of these renewable energy systems match very well with water systems. And so it's another connection between energy and water that we ought to look at. So to finish up, I think my points would be, from water security standpoint, internationally we see huge demands on water supplies. Energy, economic growth are going to make those things more competitive or a competing demand for water resources. The political climate is such that it takes a long time for groups to change their surface and fresh surface and groundwater trends, but there are alternative resources out there. They are not as energy intensive and expensive as people think. They do have a role to play in improving water availability. Thank you very much. Do I have questions? So the latest thing that I saw is I'm on till 1:45. So we got. Okay, so we have. That's what. Okay, a few minutes for questions. Couple.
I'm James LeBob. I have a question about one of your slides from about 6 back. Can you bring it back up? It was desal versus new freshwater supplies.
This
Yes,
This one here?
Yeah, explain to me, or maybe I didn't hear the explanation, why there are 2 blue and 2 brown lines. What are those?
Well, you know, if I was a lawyer, I'd give you one line, and as an engineer, these are kind of the extremes, high and low. Range. Oh, this gives you range. So I'm not trying to convince you that exactly at 2001, everything would be better to go desal. This is kind of the trends that I see. And so somewhere between 1995 and out 2020 or so, you're going to see a lot of these communities begin to switch to potentially brackish water because as they, depending upon, you know, where their water supplies are and things like that. Does that, it's a trend. It just gives you a high and a low for what the trends are. Okay. Other questions?
Hi, I'm Tam Voynick. I know that when you're talking about water security, you're talking about whether there's enough, but it made me think there's another type of water security, which is the safety of the quality of the supply. And are there costs associated with that anyone's been calculating or estimating? Sure.
We generally talk about water surety at Sandia, which is safety, security, reliability. You need all of those. Quality is becoming a concern. If you put too many requirements on water quality, it's a huge cost driver and energy driver. So some things that we're doing from a water quality standpoint do have impacts on cost and freshwater availability. So you have to balance those, and that's part of the integrated planning process, because if we see things like in California where the California Coastal Commission says we don't want to put any power plants on the coast, and the California Energy Commission says we really need to put all of our power plants on the coast so we don't use fresh water. They're at odds with each other. Both regulatory commissions that are saying different things to the same people. It's a real problem. So you've got to put that in context with the whole system, and so water safety and water quality need to be talked about at the same time as you're talking about water quantity. Does that answer your question? I mean,
yeah.
It is becoming an issue and needs to be looked at. Okay. Well, thank you very much. Appreciate it.